Now we continue this class with synthesis of procaine. Procaine is also known as novocaine. Procaine or novocaine. In this synthesis, first of all, we synthesize our intermediate compound 2-diethyl aminoethanol, and then it is treated in synthesis. So, first of all, we synthesize our intermediate compound for procaine. For 2-diethyl aminoethanol is synthesized from ethylene oxide and diethylamine. Here the structure are stated is ethylene oxide. This is ethylene tricyclic compound ethylene oxide, and this is diethylamine. So first of all, this ethylene oxide and diethylamine are condensed, and we get 2-diethyl aminoethanol. 2 we get 2-diethyl aminoethanol. For this synthesis, it is our compound number 1. Now, we start with para-nitrobenzoic acid. Stated structure is para-nitrobenzoic acid. This para-nitrobenzoic acid is treated with phosphorus pentachloride PCl5. So we get 4-nitrobenzoyl chloride. Carboxylic group COOH. This is COOH is converted into carbonyl chloride. So we get 4-nitrobenzoyl chloride. Now this 4-nitrobenzoyl chloride is treated with our compound number 1, that is 2-diethyl aminoethanol. So we get 4-nitrobenzoic acid to diethyl aminoethyl ester. Here reaction takes place between this COCl and this OH. Hydrogen from compound number 1 and chlorine from 4-nitrobenzoyl chloride. So hydrochloric acid is removed and we get 4-nitrobenzoic acid 2-diethyl aminoethyl ester. Now this is treated with acid metal reduction in presence of iron and hydrochloric acid, iron Fe and HCl. In presence of acid metal reduction, 4-nitrobenzoic acid 2-diethyl aminoethyl ester is converted into 4-amino. It is noted that this is NO2 is converted into NH2. So we get 4-amino benzoic acid to diethyl aminoethyl ester. It is known as procaine, or its known name is also novocaine. So procaine, novocaine, or IUPAC nomenclature of this is 4-amino benzoic acid 2-diethyl aminoethyl ester. So we from this route we synthesize procaine or novocaine. Now medicinal application of procaine or novocaine. The free ester is an oil, but it is isolated and use as the hydrochloride salt, which occurs as an odorless white crystalline powder that is stable in air, soluble in water 1s1, alcohol in 1s13, but much less soluble in organic solvent. So these are the properties of procaine or novocaine. Now, it is a powerful anesthetic, but is not as rapid in its action as cocaine. With compared to cocaine, it is very slow. Next point, it elicits an activity which is approximately one-eighth that of cocaine. It is noted that approximately one-eighth than the cocaine. Now, it is not habit forming. In cocaine, the disadvantage is cocaine is habit forming, but novocaine or procaine, it is not habit forming, is non-irritant and much less toxic than cocaine. The low toxicity of procaine believed to be the result of its rapid destruction esteries in the blood and tissues. It is widely used as spinal anesthetics. It is very important point. Procaine or novocaine is widely used as a spinal anesthetics. In spinal, any surgery, most of surgeons are use procaine or novocaine. Next point, procaine hydrochloride has been administered intravenously as an analgesic in the treatment of burns, for arthritis, as a substitute for morphine in post-operative care and in serum sickness. Procaine administered intravenously may be dangerous. These are the very important medicinal application and properties of procaine or novocaine. Our last compound for this class, stovain. Synthesis of stovain. Stovain is synthesized from acetone. This acetone is treated with aluminum trichloride AlCl3. So chlorine group is introduced as substitution of this hydrogen, and interaction between acetone and aluminum trichloride, we get 1 chloropropane 2 on. Here acetone ketone group is on second position, so the name of obtained compound is 1 chloropropane 2 on. This 1 chloropropane 2 on is treated with dimethylamine. Dimethylamine CH3 twice NH or NH CH3 twice. So replacement of chlorine by amino group, we get 1 dimethyl aminopropane 2 on. 1 dimethyl aminopropane 2 on. This 1 dimethyl aminopropane 2 on is treated with C2H5MgBr, ethyl magnesium bromide. It is also known as Grignard reagent. Grignard reagent. So our compound 1-dimethylamino-propane 2-on is treated with ethyl magnesium bromide gives 1-dimethylamino-2-methyl-butane 2-all. I repeat the name 1-dimethylamino-2-methyl-butane 2-all. This 1-dimethylamino 2-methyl-butane 2-all is treated with C6H5COCl benzoyl chloride C6H5COCl. So the hydrogen from alcohol group, hydrogen is from here, is substituted by benzoyl chloride and we get our final product stauine. Chemically, it is known as benzoic acid 1-dimethyl aminomethyl 1 methyl propyl ester. So, from this route, we synthesize stauine from acetone. Now, medicinal application of stauine. It is mainly used as a spinal anesthetic. This is the synthesis and medicinal application of stauine. We will study about antispasmodic drugs. First of all, we show the introduction and then synthesis of the antispasmodic drugs. So, first of all, we start with introduction of antispasmodic drugs. The term antispasmodic represents a group of drugs which are used to prevent or check the induction of spasm. It is very important point. The term antispasmodic, I repeat that, the term antispasmodic represents a group of drugs which are used to prevent or check the induction of spasm. By the term spasm, it means the violent contraction of the involuntary, that is smooth muscles like intestine, stomach, heart, blood vessels, etc. caused by the excessive amount of acetylcholine. Our some parts of our body, some parts have involuntary muscles like intestine, stomach, heart, blood vessels, etc. have involuntary muscles. The main function of the antispasmodics is to regulate the abnormal muscular activity to the normal level by preventing the acetylcholine from exercising its stimulatory action. Thus, the antispasmodic drugs have anticholine action. Due to this reason, antispasmodic drugs may also be known as anticholinergic drugs. So, antispasmodic and anticholinergic drugs are both same. The latter drugs also include another group of drugs called curative drugs, which induce an abnormal relaxation of the muscular system. It is to be remembering that curative drugs are more powerful than antispasmodics, which bring the muscles to a normal state. In earlier times, the two naturally occurring alkaloids called atropine and papaverine were used as antispasmodics, and according to our syllabus, we synthesize these two compounds, atropine and papaverine. So in this class, we synthesize atropine and papaverine and then their medicinal uses. So these are the two naturally occurring alkaloids. The biological action of papaverine is musculotropic, while the biological action of atropine is neurotropic. The various available antispasmodics may be divided into following three main groups. There are the three main types of antispasmodic drugs. Number one, the atropine group. Number two, the papaverine group. And number three, miscellaneous antispasmodics. So we discuss these one by one. All three groups we discuss in this lecture. First of all, the atropine group. Atropine is an important member of the Miscellaneous alkaloids. Noted that the name Miscellaneous alkaloids. It occurs in deadly nightshade together with Iosamine. Iosamine is optically active but readily racemized to atropine when warm in an ethanolic alkaline solution. Thus, atropine is plus minus iosamine. It is very important. Thus, the atropine is plus minus iosamine. Second group is papaverine group. It is one of the main constituent of opium alkaloids. It is noted that opium alkaloids. The structure of papaverine was established by Goldsmith and his co-workers in 1883. The scientist which established the structure of papaverine is Goldsmith in 1883, and their work is very good example of application of oxidation degradation to structure determination of the alkaloids. And last, number three, miscellaneous antispasmodics. Beside atropine and papaverine, in derivatives, there are many compounds which have antispasmodic activity. Some of these are octine, cyvarine, cystone, benadryl, etc. miscellaneous antispasmodic compounds. In this class, we studying two compound. One is atropine and second is papaverine. So, in this lecture, we synthesize atropine. First of all, atropine. Atropine is synthesized from phenylacetic acid. And in this synthesis, first of all, we synthesize tropic acid and second compound tropanol. And this tropic acid and tropanol on condensation gives atropine. So, first of all, we synthesize tropic acid. In this synthesis, it is our compound number 1, and then we synthesize tropanol. This is the compound number 2. So first of all, we synthesize tropic acid, and in atropine, tropic acid is synthesized from phenyl acetic acid. Here stated structure is phenyl acetic acid. C6H5CH2COOH, phenyl acetic acid. This phenyl acetic acid is treated with salt of magnesium chloride, that is known as isopropagyl magnesium chloride, CH3 twice CHMgCl. Interaction between phenyl acetic acid and this magnesium chloride salt gives Grignard reagent. We see the reaction, we get Grignard reagent. Now this Grignard reagent is treated with HCHO. It is known as methanol. HCHO, methanol, or methanaldehyde, aldehyde compound. So after interaction between Grignard reagent and methanol, we get tropic acid. Here we see in this reaction magnesium chloride salt is removed and methanol group is introduced, and it is derivative of carboxylic acid, so it is known as tropic acid. In this synthesis, this is our compound number 1. Now we synthesize our compound number 2, that is propanol. So first of all we synthesize propanol. This propanol is synthesized from three main compounds which describe here. Succinaldehyde, this is the aldehyde derivative. Second is methylamine. And third is calcium acetone dicarboxylate. These are three main compounds for the synthesis of propanol. Succinaldehyde, methylamine, and calcium acetone carboxylate are treated each other, and we get our compound calcium 10 methyl 4 oxo 10 aza bicyclo 5 to 1 decane 3 5 dicarboxylic acid. I repeat the name: calcium 10 methyl 4 oxo 10 aza bicyclo 5 to 1 decane 3 5 dicarboxylic acid. This calcium 10 methyl 4 oxo 10 aza bicyclo 5 to 1 decane 3 5 dicarboxylic acid is treated with warm hydrochloric acid. Here hydrochloric acid is converted calcium dicarboxylate into carboxylic acid. So with the treatment with warm hydrochloric acid, we get 10 methyl 4 oxo 10 aza bicyclo 5 to 1 decane 3 5 dicarboxylic acid. Here noted that this calcium dicarboxylate are converted into carboxylic acid. Now this 10 methyl 4 oxo 10 aza bicyclo 5 to 1 decane 3 5 dicarboxylic acid is under treatment with decarboxylation. I repeat, the treatment with decarboxylation. and then after decarboxylation we saw in reaction our this carboxylic group is removed and we get 10 methyl 10 asa bicyclo 5 to 1 decane 4 on only ketonic group, that is 4 on. So after decarboxylation we get 10 methyl 10 asa bicyclo 5 to 1 decane 4 on. After this, the product 10 methyl 10 asa bicyclo 5 to 1 decane 4 on is treated with acid metal. Here metal is Zn and acid hydrochloric acid. So this compound is treated with zinc in presence of hydrochloric acid. We get here noted that the CO group in presence of Zn plus HCl, this CO ketonic group is converted into alcohol, and we get our compound number 2 tropanol. Tropanol is chemically 10 methyl 10 asa bicyclo 5 to 1 decane 4 all. I repeat the name 10 methyl 10 asa bicyclo 5 to 1 decane for all is known as tropanol, and in this synthesis this tropanol is our compound number 2. So in this synthesis we first of all synthesize tropic acid and propanol. Now, these tropic acid and propanol are condensed and we get our final product atropine. In condensation reaction, hydrogen from tropic acid, H from here, C double O H, and OH from propanol, OH from here, and removal of H2O. So after condensation we get atropine, and chemically atropine is known as 3-hydroxy-2-phenyl propionic acid 10 methyl 10 asa bicyclo 5 to 1 dec 4 while esters. I repeat the name 3-hydroxy-2-phenyl propionic acid 10 methyl 10 asa bicyclo 5 to 1 deg 4 while ester. This is the synthetic route of atropine. This is the route of synthesis of atropine from tropic acid and tropanol. Now we see the medicinal application of atropine. Atropine is a strong antispasmodic drug. It controls spasm in many ways. It is specific antidote to prevent the muscarinic effect of acetylcholine accumulation such as vomiting, abdominal diarrhea, salivation, sweating, bronchoconstriction, and excessive bronchial secretions. This is the very important application. Atropine is used in some of the very important effect in our body like vomiting, abdominal diarrhea, salivation, sweating, bronchoconstriction, and excessive bronchial secretions. It is used intravenously but does not protect against respiratory failure due to the depression of the respiratory center and the muscles of respiration. Due to those and other side effects and toxicity, many attempts were made to synthesize antispasmodic in which either the acidic or alcoholic or both of the fragment of atropine are replaced by other compound to form antispasmodics of good quality. In earlier attempts, tropines, that is, salt of tropine and organic acids, were synthesized. Later on, tropine was also replaced by the other appropriate acids. It is to be remembered that antispasmodic properties of the synthetic product are compared with that of atropine. This is the synthesis and medicinal application of antispasmodic drugs atropine. Thank you.